Hey there, this is Anthony from mycodeteacher.com, and in this lesson I'm going to show you how to use the iPhone's touch tracking API. So of course one of the greatest things about the iPhone is the fact that it is fully touchscreen. The entire screen responds to touches. But one of the greater things about the iPhone is that Apple has created an environment in which developers can respond to these touches in any way they'd like. So you can retrieve the exact location at which the screen was touched in any view and do with this information whatever you want to. So let's first create an Xcode project. Go to File, New Project here. We're going to choose window-based application because this is going to be a relatively simple application. We'll title it Touch. So we'll save that to the desktop. And now, in most other lessons, we do a lot of the coding from the application delegate class, so the app delegate. So in this case, it would be touch app delegate. But in this application, what we're actually going to do is we're going to create a UI view subclass and do all of our coding from that UI view subclass. So any view can respond to touches, and the way it works is when a view is touched, either the developer has to use some predefined methods to deal with that view, or if the developer chooses not to, that view will pass on those touches to its subviews in the case that those subviews are in the way of the touches. So basically these touches will get passed on to subviews that they're touched in until one view decides to deal with it. Of course, if no view decides to deal with these touches, then they're ignored. We need to create a UI view subclass that deals with or responds to these touches. So first, let's click on the classes folder here because this is where we want to add our UI view subclass. And we're going to go to File, New File, and we're going to select in the subclass dropdown UI view, and we're going to create a UI view subclass. So we'll just call this custom view. Save that. Now you can see that we've got our custom view.h and .m files, and you can see in the .h file that it already is told to be a subclass of UI view. We've got here some methods that are already filled out in it with frame, draw rect, and this is where if you choose to create the view all in code, so add all subviews in code and whatnot, you can do that here. And of course the deop method. So the first thing we need to do is we need to create this view in Interface Builder. So we're going to create our custom view in Interface Builder, and then we're going to set in Interface Builder, we're going to set that view as the class custom view. So we'll see what that means right now if that confused you. We're going to open main-window.zib, and now what we need to do here is create this. So go to the library and we're going to drag on a UI view. And now you see, if you don't already have the inspector panel open, go to Tools, Inspector, and now we're going to click on the Identity Inspector. And here you can see there is a text field that says class, and what that means is the class that this object is. By default, it is of course a UI view. We're going to change that to custom view. So now this view is the of class custom view of our UI view subclass. So if we go back to Xcode, whatever we do to code to this custom view will also be done to that UI view instance or custom view instance that we just created in Interface Builder. So the first thing we're going to want to do is we're going to look at the documentation here and look at what kind of methods we need to use. So if we look up UI responder, you can see here that all objects that respond to user interaction are subclasses of UI responder. UI views, of course, fall into this category mainly because they can respond to touches. So all subclasses of UI responder implement these four methods here: touches begin with event, touches moved with event, touches ended with event, and touches canceled with event. So by default, these are implemented with some code that simply passes down these touches to its subclasses. We're going to override this implementation and actually deal with these touches. So these methods will be called automatically. When a user touches our view, these methods will automatically be called to, so we don't actually have to take care of that. So as you can see already, a lot of the work is done for us. So let's X out of this, and let's just type up the method headers here. So first, touches began, NSSet. Now, because of the fact that the iPhone can deal with multiple touches, instead of passing in one touch, we have passed here in a set. So a set of touches with all the touches. UI event. So this is we'll track the event that caused the touch. Now we're going to close this. And now we're going to use the touches moved. So as you might imagine, when touches begin on the screen, when the user first puts their finger down on the screen, touches began will be called. And if the user chooses to move their finger around and hold it down the whole time after they began to touch, the touches moved method will be called to continuously until the user ends the touches, at which case the touches ended method will be called to. So now we've got our method headers here, and we don't actually have any code. So what our goal here is we're going to create an instance of UI label, and we're going to have that label move around the screen and basically follow touches or follow the user's finger. Of course, we're going to be using the simulator, so in this case, it's going to follow the mouse. So what we're going to do now is we're going to go back to mainwindow.zib, and we're going to actually create a label. So let's drag this into our custom view, and we'll just fill in some text, touch label. Now at this point in time, this is just a stationary label. Of course, if we were to build this application, it wouldn't move. We need to actually fill in the code. But the first thing we need to do is we need to connect this to an Interface Builder outlet. So we've created a label in Interface Builder, and at this point in time, there's no connection to the code. So we need to make this label representable in code. So we're going to use an Interface Builder outlet and an instance variable, UI label, main touch label. Now we need to save this, and now let's connect this in Interface Builder. So this is our custom view, and this is our label. So we're going to right-click and drag from our custom view to this label, which of course exists inside the view, and connect the outlet. So now we can deal with this or manage this label from code, or in this case, have it respond to touches. So now let's actually fill out our code here. So the first thing we need to do is we need to get the touch object out of the set of touches. So touch equals touches any object. So again, this method is called, and passed in is an instance of NSSet, which contains all the touches on the screen. This application is only going to deal with one touch, so we just need to grab this one touch. So there's a method called anyObject, and it's in many cases it returns a random object in a set. In some cases, it's not guaranteed to be random. It's, according to the documentation, when an NSSet object receives the anyObject message, it will return any object at its convenience. So not guaranteed to be random, but will be random in many cases. But of course, this set we're going to assume only contains one touch because we're only going to deal with one touch. So this set has only one object in it. Now we have our touch object. Now we need to use it. So first, we're going to create a CG point. A CG point is just a C struct which contains X and Y floats. We're going to call it location of point equals touch location in view self. So now what we've done here is we've called to the location in view method. We're going to send that to our touch, and depending on what view is passed in the parameter here, this touch object will return a point of the location in that view that the user touched. So of course we want to find out where the user touched in this custom view here, so we're going to pass in self. So what we're saying is touch object, where did the user touch in this view? And it's going to return a point containing x and y coordinates of exactly where the user touched. Now we're going to create a CG_rect object main touch label frame. Now what we're doing here is we're getting the current frame of the main touch label. So you can change how the boundaries, the frame of a UI label and its origin simply by modifying its frame or giving it a new frame. So what we're doing here is we're grabbing its current frame by accessing its frame property, and this CG_rect is a struct containing two more structs. So let's take a look at the documentation here, because it might seem a little bit confusing at this point. You can see here a CG_rect is a struct which contains two more structs. One struct that contains origin and one struct that contains size. Now we're not going to modify size because we want the size of this label to stay the same size it already is. So we're basically grabbing its current frame, we're going to change its origin, or where it is, and then set it back to itself, or set it back to its frame. So let's change this origin here, equals this frame, we're going to change the origin, CG_point_make. Now we're going to use a function, a C function called CG_point_make, which returns a CG_point struct containing x and y points. X location. So now what we're doing here is we're passing in as these parameters. The CG_point_make function takes two parameters. The first one is the x coordinate of this structure, and the second one is the y coordinate of the structure. We're creating a new frame that contains the origin, an origin that is the x and y coordinates of the last touch. And then now what we're going to do is we're going to set the touch label, we're going to set its frame back to that frame that we just created. So let's go through this again, because that all might have confused you. So there was a lot going on there. First, we grabbed the touch object, where the UI touch instance, which contains information about where the user touched. Then we created a CG point, calling it location of point, of where the user touched the view. Then we grab the current frame of our main touch label. Again, a CG_rect is a struct containing an origin, x and y coordinates of that object, and CG_size, the size of that object, height and width. Then we change the origin of that previous frame of our touch label. We gave it a new origin, which is the origin of where the user touched, the location at which the user touched. And then last, we set the main touch label's frame back to the new frame, or the modified frame. So now, let's build this and see what we've got so far. If we touch on the screen, you can see that the touch label moves to wherever we touch the screen. Now let's make it so that if we hold down and drag, it follows us still. So all we need to do is just copy this code from the touchesBegan method to the touchesMoved method. Now if we build, you can see that after we touch and drag, it follows. So now we're going to make this a little bit cooler. We're going to actually add some animation. So we're going to make it so that when the touches begin, instead of just instantaneously reappearing at where the touches began, we're going to make this touch label slide to where the user touched. So UI view, begin animation, this is a class method, nil, begin animations nil, context nil. Doing animations with the iPhone is very simple. So what we do here is we use a class method, a UI view class method, begin animations nil, context nil, and so now any interface changes we make will be animated inside. Now what we have to do is, underneath all of our changes, we call to another class method, UIView commit animations, and now all of the animations will be done. So let's build this. You can see that if we click, it slides. Now, of course, you can change some animation properties like the duration. Set animation duration. We'll set it to 1 full second, so this should happen pretty slowly. Let's see how that works out. You can see that responding to touches at this point is very simple with the iPhone SDK. It didn't require a whole lot of code, maybe some code you've never seen before, but once you get the hang of it, it makes a lot of sense, and it's very, very powerful, and you can do a lot with it. And as you've probably seen in the App Store, a lot of developers have already begun doing many things with touch response with the iPhone. So I'm Anthony from mycodeteacher.com. That concludes this lesson on responding to touches. I hope you learned a lot, and I hope you enjoyed it, and I hope to see you in future lessons.